Wiles, and in this video we'll be talking about triangles, specifically isosceles, equilateral, and right triangles. These are special triangles who think they're something great and grand. And they are a little bit, because we can find some things that will apply to all of them and so forth. In a triangle, as you know, you have three legs, you have three vertices, the corners of the triangle, and you have angles in the triangle, you have side lengths in the triangle, you have all that. There are some specific vocabulary terms that you need to know when it comes to isosceles triangles. When it comes to an isosceles triangle, and the way that we can tell without them telling us that it's an isosceles triangle is if we have two sides that are marked by the same number of marks to show that they are equal. The other side either could be left out where it doesn't have any marks at all, or it could have a couple of other marks, especially if it was being compared to another triangle. It might have some marks too, but only two of the sides would have the same number of marks. The same number of marks shows that those two sides are congruent, and that they are called legs. In an isosceles triangle, you might have thought that only right triangles have legs, but in isosceles triangle, the two sides that are equal also are called legs. Differently than a right triangle, because in a right triangle you have two legs and what? In a right triangle, a hypotenuse. Yeah, in a right triangle you have two legs and a hypotenuse. In an isosceles triangle you have two legs and the base. There are some things that are always true, and that's when you'll see this word theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. So and you can follow where I'm going with the cursor. So if this leg is equal to or congruent to this leg, then this angle, and I'll mark it now, is congruent to this angle. Some other things are words like opposite. This angle, I'm going to call it angle A now, is opposite side A. And this angle on the lower right, I'm going to call it B now. It is opposite side B. Remember that the B is going to be equal to A, because that's the definition of an isosceles triangle. So you can take all this information, and there are things that you can find out. Like, I could just give you one angle up here and you can find the other two. If I tell you that the vertex angle here, and I'll call it C, if I tell you that that is 34 degrees, then you can find out what the other two angles are by using everything you know about triangles. So when you think about triangles and all three angles, what should those angles add up to be? 180. So if I know that C is 34 degrees, and I know that A and B are equal because they are in an isosceles triangle, the sides are equal here, and I can take that 34 and I could subtract it from 180, and that leaves me 146 degrees that I need to split up between B and A. They need to be split up, and they're going to be split up evenly because they're equal. So I divide that by 2. We don't write it like that anymore. We just write it as a fraction. So 146 divided by 2, and each one of these angles is 73 degrees. Now, can I tell anything about the lengths of the sides? No. I don't have enough information here at all to tell me anything about the actual length of the sides. All I know is that side B is equal to side A. I don't know what they are. And they could be different. I could have a triangle with the legs and the base of this length. I could also have a very similar triangle with the same angle measures, but different side measures, because it's all about whether it's, the angle measures can be the same, but it's about the ratio of those sides to another. So what these theorems over here say, you have your base angles theorem. If you see words like that, you may not be able to recite what you see here. If two sides of a triangle are congruent, then the angles opposite them are congruent. But the title of the theorem, the base angles theorem, here's how you think about whether this theorem is something that you're using to prove something. If I can come to the conclusion about the base angles, then what's going to help me come to that conclusion about the base angles? The name of the theorem is the conclusion that I want to make. The conclusion I want to make is that angle C is equal to angle B. And what is it about isosceles triangles, or any triangle, that's going to help me do that? And I have to be able to recall that. And then the converse of the base, converse is not something you put on your feet. Converse is like the inverse, the opposite. Why is it called converse? The same reason other things are called two different words. Like your elbow is called your weenus. Have you never heard that before? I mean, it's something that, like your finger is called your phalange. And I didn't know that. But it's just a different word. It means the same thing. There are lots of words like that because we have to be special. Now, there are some other things that you may have picked up on. If a triangle is equilateral, it is also equiangular. Now, what do those two words mean? Equal sides, equal angles. There's a relationship. If a triangle has equal angles, then it is equilateral. That's a big side. Nothing earth-shattering yet? These are the things that we're going to use to be able to figure things out. All of this knowledge gets put into somewhere, and you hope that you can access it whenever it's necessary to figure something out. Let's go on here. So we use it, we get some kind of triangle that looks like this. You know, you've got two triangles put together to make one other triangle. You've got some sides that are corresponding. You've got all this stuff going on, and maybe it seems jumbled up to you. And if it does seem jumbled up to you, then separate it. You know, actually take your paper and separate it. And you have this angle, and you have that angle. Okay? And they're sketches, so you just realize what you're doing. But if you can keep things straight on the original drawing, that's the best way to go. If you keep things straight. So you look at what you have here. If I have this side is equal to this side, is equal to this side, is equal to this side, they're all equilateral. They're all equilateral, which tells me that the angles are equiangular. So if I'm looking at these and all four of those sides are exactly the same, then doesn't angle X have to equal angle whatever this is? And whatever this is? Now, does it look like it? No. The drawing doesn't look like it, but the marks are telling me that it is. And if the marks are telling me that all three sides, if the marks tell me that all three sides of the angle are exactly the same, then it tells me that all three angles are exactly the same. And I have three. If that's angle X, then so is this one. And so is this one. And if I add them all together, what does it have to equal? It has to equal 180. And then I divide by 3, and x equals 60 degrees. And if the other side has an angle that is, or a side that is equal to the sides that are in the first one, no matter what that drawing looks like, that tells me that the same thing is happening over there. And so what is angle y? Angle y is also 60 degrees. So I take that information and I apply it. There are 4 ways to prove that triangles are congruent. Now, so far, I've had you looking at them and figuring it out. And what you've really been using are what these are called. You've been using these congruence postulates when you look at a diagram to see if it's correct or not. So what I'm going to be asking you to do today after this video is to be able to call it what it is. Why can you say that these 2 triangles are congruent? And we'll look at each one of these separate. So we're going to go to the first one first, and it's the side, side, side. So with the side, side, side congruence postulate, what I want you to see is that if I have 2 triangles, and I don't care what they look like. I don't care if they look similar or what they look like. What I want you to look at are the marks. If I tell you that this side of triangle A is congruent to this side of triangle B, and this side of triangle A is congruent to this side of triangle B, and if I tell you that this side of triangle A is congruent to this side of triangle B, I don't give you any other information. If that is information that you can take from a drawing or from a description or anything else, then you can say that these 2 triangles are congruent because of the side, side, side congruence postulate. And you'll see some other words used too. The next postulate is side, angle, side. So I have 2 triangles. They don't look very congruent. But if I say that this side is congruent to this side, and that this angle is congruent to this angle, and that this side is congruent to this side, I'm going to call those side sub 2. Then you can say that these 2 triangles are congruent. Now, it says side, angle, side, and that order is important. So it has to be one side, 2 sides, and the angle that is in between them. Not the angle here in red, not that angle, because that's not side, angle, side. You're having to, it's side, angle, what? You know, you don't have the complete side, angle, side. Next, we have the angle, side, angle. Based on the logic that we've used so far, I should find one angle and the side in between and another angle. So maybe, that makes it appears that this would be a side that they share, that these 2 angles share. So if I have an angle here, or a triangle here, and a triangle here. Then if I say that this angle is congruent to this angle, and this side is congruent to this side, and the next angle is congruent to the next angle, then I have my angle, side, angle. And if I have angle side angle, then I'm able to say that it's congruent. Angle side angle. A side over here would not be okay, because we would be going side, angle, angle. And that's not enough. There has to be something in common that they have with each other. Unless it's all three sides or all three angles. That's what they're trying to do with these other three, is to break it down so that you don't have either all three sides or all three angles. You have some other combination. And then finally, angle, angle, side. Angle, angle, side. Got my ugly triangles again. I'm going to label these. I'm going to label it A, B, and C. I'm going to label the sides A, B. Nope, that wouldn't be good labeling. B should be across from that, so I'm going to name that C. A, B, C, D, E, F. And remember, it could be, doesn't have to be all nice and neat like this. For this to work, I want you to think about that relationship. Angle, angle, side. Angle A would have to be congruent to which angle? D. Angle B would have to be congruent to E. Or maybe it's F. You know, it just depends on how the triangle's rotated. And it doesn't even matter if it looks exactly the same. If they say it's equivalent, you know, that it's congruent, it's congruent. But if these two sides are the side, or these two angles are the angles that are congruent, what side would come next? C. No. A. Which one? The small and the lowercase. Could it be either? Well, I'm asking so that you'll think. Okay? If I go angle, angle, side, is that true? Angle, angle, side. But if I go angle, angle, side, is that true too? Yeah. So either way. But side A would have to be congruent to side D. They would have to be congruent. Or side E would have to be congruent with side B. Either one, not both. Either one. That's all I have to say about that.